All right, today we're going to be looking at molar mass conversions, and one thing I want us to build as we're learning new pieces is our toolbox. So at the top of the page, write toolbox, and we're going to add to this every time we learn something new in stoichiometry. And the thing we learned yesterday, or the first thing we learned, was mole ratios. And this gets us from moles of one chemical to moles of another, and I'm representing that with moles of A to moles of B. Okay, so meaning moles of one chemical to moles of another, and we do that using the coefficients of the balanced reaction. Okay, wow, that's really important because that actually gets us between chemicals within a reaction. We don't have a piece of equipment that measures moles, but we do have a piece of equipment that measures grams. So now we're going to look at making a connection between grams and moles. Okay, so molar mass can be used to convert between the moles of a chemical, or essentially how many atoms or molecules of that chemical we have, and grams of the same chemical. So molar mass can be used to convert between the moles of a chemical and grams of the very same chemical. And we need to use this because there is not a piece of equipment that can measure moles. But we can measure grams. So we use this because there's not a piece of equipment that can measure moles, meaning count our numbers of atoms or molecules. But we can use a scale or a balance to measure grams. All right, we've already looked at how to actually calculate this. And so let's just focus in on the units real quick and talk about how does that relate to what we need for this today in terms of ratios. All right, remember, stoichiometry is a ratio game. Okay, it's all about figuring out the ratios. So far we had some grams per mole, some number of grams per mole of a chemical, yeah, that we used to calculate, that we got from the periodic table. Okay, so what does this mean then if we're expressing this as a ratio written as a fraction? Well, I would have some number coming from the periodic table based on how many atoms there are in the compound in grams of chemical A over 1 mole of chemical A. These two things are expressing the same thing. It is the same unit. Okay, we have some number of grams for every 1 mole of that chemical. All right, but it's a ratio, which means that I can also write it from the other perspective, where I can say 1 mole of chemical A has a mass of a certain number of grams of that chemical. These two are expressing the same thing. It's the same relationship. The number of grams of chemical A is a mole of that chemical, and a mole of that chemical has a mass of this many grams of that chemical. It's just another ratio. Like saying 1 bicycle has 2 bicycle tires, and there are 2 bicycle tires for every 1 bicycle. It's a ratio. It's the same relationship. Okay? So if I were to actually like write out kind of a general setup, I can say that whatever I'm given, let's say I'm given in a problem some mass in grams of a chemical, I can set up a train track the same way that I've been doing so far. Okay, and if I'm going to solve this, I can use my grams and drop them down to the bottom. So grams of A cancel with grams of A. And remember, A is just a placeholder for some chemical or element. Okay, and using molar mass, I would be solving for moles of that chemical. Okay, now the tricky part is, where do the numbers go? Well, since we're always talking about molar mass for 1 mole of a chemical, I will always have 1 mole of a chemical represented by so many grams of that chemical. And this is the molar mass, which we get from the periodic table. Okay, well then I could also flip this. What if I'm given, instead of mass in grams, I'm given moles of a chemical? And I need to figure out how to set up my train tracks to then solve for that. Well, I would do the same thing. Drop your moles to your denominator so it will cancel. And I'm looking for grams of that chemical. So the issue then is, where do the numbers go? Well, it's the number of grams, which are coming from the periodic table, meaning your molar mass, over 1 mole of that chemical. So moles and moles cancel. And then we just follow our multiply on the top, divide on the bottom, just like fractions. Okay? All right, let's put this into action. So those are kind of like the general conversation about units and where they need to go based on what you're trying to find, okay? So now let's actually look at an example. I'm going to move my paper up here. Example. How many grams of CO2 are there in 100 moles of CO2? So this is kind of the first example we're going to solve. Well, reading this problem, there's only 1 chemical, and that's CO2. All right. I also see grams and moles. So let's identify what's given and what we're looking for. So what are we given in this problem? 100 moles of CO2. And what are we trying to find? The grams of CO2. So I'm going from moles to grams. Okay? So let's set up a train track. 100 moles of CO2. Step 1. Take your units, drop them down to the denominator of the other one so they cancel. Step 2, the thing that we're looking for, and this is a one-step problem, the thing we're looking for would be on the top, so that would be grams of CO2. So now I think about, what do I have that connects grams and moles of a chemical? Well, grams per mole, that would be molar mass, okay? So I'm going to solve for the molar mass of CO2. I'm going to show you how to do the molar mass for the problems today, but moving forward, you can just solve it using your calculator, and you don't have to show your work for solving molar mass. I'm going to show you today as a quick reminder, but like I said in the last unit, for this unit, you can just solve for molar mass in your calculator and use it, okay? So I've got carbon and oxygen, but as a refresher, I'm going to solve for molar mass here. So in CO2, I have 1 atom of carbon its average atomic mass on the periodic table is 12.01. So 1 times 12.01 is 12.01. In CO2, I've got 2 oxygens. The average atomic mass on the periodic table is 16. 2 times 16 is 32. So I take 12.01 plus 32 and I get 44.01 grams per mole. Okay, but let's talk about what that unit means in terms of using it as a ratio. Okay, because it is a relationship between the mass and moles. So I can express this molar mass as 44.01 grams of CO2 over 1 mole of CO2. Okay, likewise, I can say 1 mole of CO2 has a mass of 44.01 grams. This is the same relationship. It's the same ratio. It's the same relationship. It's, once again, 1 bicycle has 2 bicycle tires, or there are 2 bicycle tires on 1 bicycle. It's the same relationship. So looking at our problem, am I going to use the first ratio or the second one? The first one. Why am I going to use the first one? Because the units are what we need, right? And you can write it either way because it's a ratio. So now if I fill in my 44.01 and 1, moles CO2 cancel. What mathematical function do we do on the top? And on the bottom? Okay, so 100 times 44.01. 4,401, 4401. What? Cheeseburgers? Grams of CO2. There's your answer. Okay, so here's what this means. If I had 100 moles of carbon dioxide, I counted out all of those molecules. Holy cow, that's a lot of molecules. And I put them on a scale, it would weigh 4,401 grams, or just about 4.4 kilograms. And I can actually measure that, right? I can actually find that mass. All right, let's look at another one. Here we go. How many moles are there in 75.6 grams of C8H18, which is octane? How many moles are there in 75.6 grams of C8H18? So what I want you to do is take a second and solve this on your own. See how far you get. You don't know where you get stuck if you don't try, okay? So try to solve this one on your own. Okay, one more time. 5, I have an answer. 3, I'm still working. 1, I'm stuck. All right. Okay, let's go ahead and go over this. So help me out. What are you given in this problem? 75.6 grams of C8H18. And what are you trying to find? Moles. Okay. So this strategy of underlining what you are given and circling what you want is really helpful. Okay. So in this case, I'm going to go from grams to moles. So I'm going to set up my train track. My train is whatever I'm given, 75.6 grams of C8H18. First step is I'm going to move my units down to the denominator of the next track because I need them to cancel. And that's the only way they're going to cancel. Next, the units that I want are moles. So moles of C8H18 are going to go on the top because that's what I want. So the next thing is think, okay, what do I have that gets me between grams and moles of a chemical? There's only one thing, and that's molar mass. So I'm going to show you how to solve for molar mass here. So help me out and walk me through the steps so we can do it quick. So I've got carbon and hydrogen. How many carbons are in the compound? times the mass on the periodic table, which is, okay, so 8 times 12.01 equals how many? 96.08. Okay. Hydrogen, how many are in the compound? Times, what's the mass? So what's 18 times 1.01? All right, and what are these two numbers added together? There it is. 114.26 grams per mole. Okay, let's talk about what this means real quick in terms of writing it as a ratio, right? It is a ratio, so let's write it as such. I can say that 114.26 grams of C8H18 is representing 1 mole of that chemical. Or I can say 1 mole of that chemical has a mass of 114.26 grams. Either way, it's expressing the same relationship. It's the same ratio, okay? It's the same relationship. So if I'm looking at my problem here and what I have set up, am I going to use the first setup or the second? The second, because I need the grams on the bottom, right? So they cancel. So 1 mole of C8H18 has a mass of 114.26 grams. So now I'm ready to solve. Grams C8H18 cancels with grams of C8H18. If it's on the top, what mathematical function do we do? And if it's on the bottom, okay, so 75.6 divided by 114.26 equals 0.66. Now, if we were using significant figures, we would use 3 of them, so 0.662, but we're just going to do 2 decimal places. 0.66 what? Good. C8H18. Okay, so as a reminder, you have to have the number, the unit, and the chemical in your answer. Otherwise, it's incomplete. Okay, so this is how we use the molar mass, which we have calculated before and which we get from using the periodic table to solve for molar mass conversions.